On Friday, we started with an equation, and we converted it to a table. Then we took the table to a graph, and then from the graph on Monday's homework, we found the slope of the line. We found the slope two ways. Once with rise over run, and once with using the equation m equals y2 minus y1 all over x2 minus x1. Using the equation from Friday, this was the last problem in the assignment, y equals negative 2/3 x plus 1. You converted it to a table. But for tonight's homework, I'm not going to give you the table. You have to come up with values that will actually work on the table. In the past, I told you to plug in 1, 2, 3, 4. Well, what's the problem if I plug 1 into this equation? If I plug 1 into this equation, 1 times negative 2/3 is going to give me a fraction answer. I'm not going to use 1 on my table because I don't like working with fractions. If I plug in 2, will I get a whole number or will I get a fraction? 2 divided by 3 is still a decimal. It's still a fraction. It's still messy. So I'm not going to plug in a 2. We're going to skip those numbers. Don't use 1 and 2. But what about if I plug in a 3? Will that give me a nice pretty whole number?
Yes.
So plug in a 3. Down. When I plug 3 into the equation, 3 divided by 3 is 1. 1 times negative 2 is negative 2. We added the 1 onto it. That gives me negative 1. That's my y value. Now I have to think of another number that would work very nicely in this equation, give me whole numbers. Instead of 3, maybe we can use 6. So plug 6 into the equation. When I plug in 6 to the equation, 6 divided by 3 is 2. 2 times 2 is negative 4. Negative 4 plus 1 gives me a negative 3. That is my y value. Now that I've used positive numbers, you also want to get on the other side of the axis. So instead of positives, I now need negatives. So let's plug negative 3 and negative 6 into the equation. When I plug in negative 3, it kicks out 3 of the equation. When I plug in negative 6, it kicks out 5. So I've plugged in positive and negative numbers, and all of these happen to be multiples of the denominator. So now to go from the table to the graph, you're just going to sketch it out. You're going to draw a horizontal line and a vertical line. You're welcome to use graph paper if you want to. My x values really range from a positive 6 to a negative 6. So I really need positive 6 on the axis, on the x-axis, and I need negative 6. The same is true on the y. I need to go all the way up to positive 5 on the y. But I only need to go down to negative 3 on the y. I'm going to pause the video and plot the point. So when I plotted the points, they all made a straight line. Now, based on the graph, we are going to find the slope. The first way that we found the slope was rise over run. So look at your graph and think about how much does this rise up. To get from 3 to 5, it rises up 2 steps. Then it runs over from here to here. It went from really negative 3. This is kind of at negative 3. And it went all the way over to negative 6. You ran over 3 steps. Then you look at the graph. Is the graph going up or down? The graph was going which way? Down. So the answer is negative. Okay, I'm going to choose 2 points off the graph. You may choose any 2 points you want off the table. I happen to choose the last 2 points. You could have chose the first and the last point. It's your choice. This is going to be my second point. This is going to be my first point. Y2 is going to be 5 minus 3. 5 minus 3 is equal to 2. And I need to change the x values. The negative 6 minus the negative 5 gives you, 2 negatives make a positive. Negative 6 plus 3 gives you a negative 3. By the way, negative 2/3 is the same thing as 2 divided by negative 3. I've shown the slope two different ways. The last step is we're going to convert it back to the original equation. Really, you can just copy down your original equation. It was negative 2/3 x plus 1. And then all I want you to do is draw arrows from the slope to the first part of the equation. And then this plus 1 actually comes from the graph. I want you to circle where it crosses on the y-axis and draw an arrow to the plus 1 on your equation. The plus 1 comes from where the graph crosses the y-axis. By the way, in algebra, you're going to call that the y-intercept. But this plus 1, right now I just want you to point to where it comes from for the graph. That is what you're going to do for 4 different equations. To make a cool graph, we want to have y equals for each one of our equations, and the first number is going to be a fraction. Choose any fraction you want, make it simple. Just don't use negative 2/3 because that's what we've already done. Maybe negative 1/4, maybe 3/7, maybe 4/8. Pick any fraction, write it down. Fill in the x, then fill in a random number at the end. Keep it simple. Step 2, we're going to change the sign, and we're actually going to also take the reciprocal of the first one. So what's the reciprocal of negative 1/4? You take negative 1/4 and you flip it over. What is it? 4/1. And if I change the sign, negative is going to become a positive. Bring down everything else. So now I want you to change just the sign on the second part. So bring down everything else. Bring down the plus 4/1. Bring down the x. If we change positive 5, what's it become? Negative 5. And then the last step is I want you to do the same thing you did on the first sign. I want you to change this sign and flip it over. So negative 4/1 becomes, or positive 4/1 becomes negative 4/1. Bring down everything else. You will basically have the first and the last one's negative, and these two are negative. Make sure you take the reciprocal of the last one. So 4, so this should actually be negative 1/4 because we want to flip it and change the sign. So your first and last fractions should match. Your middle two fractions should match. If you're not sure, then you can show it to me.